Hello, class 12. Uh, we are doing surface chemistry. Last lecture, you have seen the introduction of colloidal state. Okay, so we are continuing here the colloidal state of matter. As you know, colloid is not a substance but a state of substance. Okay, लास्ट क्लास हम बताए थे कि कोलाइड जो है इट इज नॉट अ सब्सटेंस बट स्टेट ऑफ सब्सटेंस। जो ग्राहम का कॉन्सेप्ट था कि कोलाइड इज अ सब्सटेंस वो गलत है, ठीक है ना, बिकॉज द सेम सब्सटेंस कैन बिहेव एज कोलाइड एज वेल एज क्रिस्टलाइड इन टू डिफरेंट कंडीशंस। फॉर एग्जांपल, if NaCl is dissolved in water and when the solution is passed through animal membrane or parchment paper, the particle of NaCl can pass through the animal membrane and parchment paper, and therefore it is a crystalline. On the other hand, if NaCl is dissolved in benzene and when this solution is passed through parchment paper or animal membrane, the particles of NaCl will not pass through parchment paper or animal membrane. Therefore, in that case, NaCl behaves like a colloid. So NaCl in two different conditions behave as crystalline as well as colloid. Similarly, if you take a dilute soap solutions, means a little amount of soap is dissolved in water, then in that solution the soap behaves as a crystalline because the soap particles can pass through the parchment paper or animal membrane. What is soap? Soap is a sodium salt of higher fatty acid like sodium stearate C17H35COONA. These particles, these ions can easily pass through the animal membrane and parchment paper if the soap is dissolved in water in a little amount. Means dilute soap solution, the soap is a crystalline. But if the amount of soap is very large amount of soap is dissolved in water, then you can see the soap particle cannot pass through the animal membrane or parchment paper. Therefore, in that case, the soap behaves as a colloid. Actually, होता क्या बेटा? This is the sodium stearate, suppose soap. इसमें दो पार्ट होता है, एक होता है Na+ ion और एक हुआ stearate ion. If there is a large quantity of soap, then what will happen? These stearate ion will combine with each other. इसका जो ये हाइड्रोफोबिक पार्ट है, एक होता है हाइड्रोफिलिक पार्ट, एक हाइड्रोफोबिक पार्ट, वो आपस में ये हाइड्रोकार्बन पार्ट जो है आपस में कंबाइन करने लगता है, ठीक है, एंड इट फॉर्म्स अ लार्ज पार्टिकल्स हैविंग डायमेंशन मोर देन अ कोलाइडल डायमेंशंस. उसका साइज 1 नैनोमीटर से बड़ा हो जाता है, ठीक है, एंड दिस स्फेरिकल क्लस्टर, ये जो क्लस्टर है, क्लस्टर मींस एसोसिएटेड पार्टिकल, इज नोन एज मिसल्स. इसको हम लोग मिसल्स बोलते हैं. This is the micelles. We will discuss it later. And so, in concentrated soap solution, soap forms micelles, and the size of micelle particles is more than the size of the pores of animal membrane. That's why it cannot pass through the animal membrane. It can pass through the normal filter paper, but it cannot pass through the animal membrane or parchment paper. So, in dilute soap solution, soap behaves as crystalline, while in concentrated soap solution, soap behaves as colloid. It means the same substance can behave as crystalline and colloid. And what will decide the nature of crystalline and colloid? It will decided by the size of the solute particle. If the size of solute particle is in between 1 nanometer to 1000 nanometer, in between 1 nanometer and 1000 nanometer, then it will be a colloid. And if it is the size of the solid particle is less than 1 nanometer, then it behaves as a crystalline, and the solution will be called true solutions. If the size of solid particle is less than 1 nanometer, the solution is called true solution. And if the size is in between these two, 1 nanometer and 1000 nanometer, it behaves as a colloid, and the solution of colloid is called colloidal solution. And if more than 1000 nanometer, if the size of solid particle is more than 1000 nanometer, it is called suspension. You have already studied it in standard 9, but not in detail. Here we will discuss it in detail. Okay. Now, so how will you define colloidal state of matter? Colloidal state of matter is defined as the state of matter in which the size of particle is such that, means is in between 1 nanometer and 1000 nanometer, is such that they can pass through filter paper but not through animal membrane or vegetable membrane or parchment paper. Is it clear? In true solution, if you take a binary solution, binary true solution, you know one of the component of the binary solution is known as solute and other is known as solvent. One more thing, the true solution is a homogeneous mixture, but the colloidal solution is not a homogeneous, it is a heterogeneous mixture. In true solution of two substances, one is called solute and other is known as solvent. Here, in case of colloidal solution, if we take the colloidal solutions, then the one substance is known as dispersed phase and other is known as dispersion medium. Okay? One is known as dispersed phase and other is known as dispersion medium. What is dispersed phase? It is the component present in a small proportion and consists of the particle of colloidal dimension. Dispersed phase, dp. Dispersed phase, dispersed phase. Dispersed phase. What is dispersed phase, beta? So the component present in a smaller proportion, the component present in smaller proportion and consist of the particle of colloidal dimension. Consist of particles of colloidal dimension. Colloidal dimension. That is 1 nanometer to what? 1000 nanometer. The colloidal dimension is 1 nanometer to 1000 nanometer. So, in a colloidal solution, there are two components. One component is called dispersed phase and the size of the particle of the dispersed phase is in between 1 nanometer to 1000 nanometer. And the other component is known as dispersion medium. Dispersion medium. What do you mean by dispersion medium? The medium in which the colloidal particles are dispersed. The medium in which colloidal particles are dispersed. Okay, is called what? Dispersion medium. Is called dispersion medium. Right? Is called dispersion medium. So one component is known as dispersed phase and another component is known as dispersion medium. Like in a binary solution, one is solute and another is solvent. Right? Suppose we take the colloidal solution of sulfur in water. In that case, sulfur is called dispersed phase. The particle of sulfur will have dimension in between 1 nanometer to 1000 nanometer. And the water is called dispersion medium. Like in case of milk, fats are dispersed phase and fats are dispersed in water. So water is known as dispersion medium. Is it clear? Next class we will see classifications of colloids. Okay, there are three different bases on which we divide the colloids or classify the colloids. We will discuss it one by one. First, based on the physical state of dispersed phase and dispersion medium, and second, based on the nature of interaction between dispersed phase and dispersion medium, and third, based on type of particles of the dispersed phase. Okay, there will be different classifications of the colloidal state or colloids. Okay, thank you.